Chapter 1.2, use segments and congruence. Okay, so here we have points on a number line, A and B. And the points are always represented with capital letters. Now, for the coordinates of the points, in other words, what number is associated with that point, usually it is represented with lowercase letters. Okay, in this book, they used x1 and x2 because this number line is basically the x-axis since it goes left to right. But what I am going to do is just use lowercase letters. So I'm going to change x1 and x2 to lowercase a and b. So lowercase a and b will be the coordinates of the points. Okay, and the coordinates will be the number that is associated with that point, because like we said, this line here is a number line. So again, we have points A and B on the number line. Okay, and if you see AB with no bar on top, that represents the distance from A to B. In other words, if you see AB with no bar on top, AB is the length of line segment AB. Okay, so here they give us the formula for the distance or length of AB. You just subtract the two coordinates, x2 minus x1, and then you take the absolute value. Okay, so that's what these bars are on the sides. All right. And like I said, instead of x1 and x2, I like to use lowercase a and b, so that would look like this. So a and b, lowercase, would be the numbers associated with the points a and b, and you just subtract a minus b and then take the absolute value. By the way, the order that you subtract does not matter when you use absolute value. So you can also say b minus a absolute value. It's the same thing. Those are equal. Okay? And just to prove it to you, if, for example, you have the absolute value of 5 minus 3, we know that 5 minus 3 is 2. And when you take the absolute value of 2, you just get a 2. Now, if I reverse these two numbers and did the absolute value of 3 minus 5, I know that 3 minus 5 is actually negative 2. But then when you take the absolute value, you will still get positive 2. So notice I can reverse the numbers when subtracting with the absolute value function, and it will give you the same answer. Okay, example 1, measure the length of segment ST to the nearest tenth of a centimeter. Okay, so instead of a number line, they gave us a ruler on the screen, but that is basically the same thing. Okay, they gave us the ruler in centimeters. So let's see. We see that the S, if we trace that down to the ruler, that's this line right here. That is a 2. So that's going to be my lowercase s. And for the T, if you trace that down to the number line, I'm assuming this counts by 10, right? So this is 5 by tenths, 5, 5.1, 5.2, 5.3, 5.4. So this here is going to be a 5.4. And since that's for point T, we are going to call that 5.4 the lowercase t. All right, so this is on the ruler. And since we want to find ST, we can use the formula. You take the absolute value of S minus T. Or You can also do the absolute value of t minus s. Same thing like we said before. Okay. Now, since the bigger number is 5.4, I would rather put the bigger number first. In my opinion, that's easier. So I'm going to do t minus s. Okay, so we see that t is 5.4 minus s, which is positive 2. 5.4 minus 2 is 3.4. And taking the absolute value changes nothing. So the answer is 3.4. Just so everyone knows, an absolute value changes the negative to a positive. Okay, if it's 0 or already positive, it does nothing. So the absolute value of 3 is just 3. But if you have the absolute value of negative 3, that will make it positive 3. That's what absolute value does. All right, and like we said before, if you reverse these numbers, if I did s minus t, okay, I would start with 2 and then minus 5.4. So if I did it backwards, 2 minus 5.4, if you can't do that in your head, do it on the calculator. That would be negative 3.4. But then once you took the absolute value, it's positive. Okay, so like I said, the order of subtraction doesn't matter when you use absolute value. So I would rather put the bigger number first. Okay, and the units on the ruler were in centimeters. So if you wanted to include the units, we can just write 3.4 centimeters. All right, so when 3 points are collinear, that means they are on the same line. You can say that 1 point is between the other 2. Okay, so in this case, these 3 points are collinear on the same line, and point B is between points A and C. However, these 3 points are not collinear. Okay, so point E is not between points D and F. All right, you can see point E is not on the line, so that is not between points D and F. Okay, if B is between A and C, then AB plus BC equals AC. And if AB plus BC equals AC, then B is between A and C. So right here, these points are collinear. They're all on the same line. We see that point B is between A and C. So we can say that AB plus BC equals AC. Okay, we're just adding the 2 smaller pieces, and that equals the whole thing. Okay, in terms of length, AB plus BC equals AC. Okay, those are just the lengths of each segment. So in other words, they are saying that this plus this equals that. Okay, they're adding the 2 smaller pieces, and that equals the whole thing in terms of length. Okay, example 2, the cities shown on the map lie approximately on a straight line. Use the given distance to find the distance from Lubbock, Texas to St. Louis, Missouri. Okay, let's take a look. So this point here, L, that is Lubbock in Texas. And this point here, S, is St. Louis. So we're looking for the distance of this entire line. Okay, So what we're going to do is add the two pieces. All right. So if you go from L to T, that's going to be 380 miles. And if you go from T to S, that's going to be 360. So we're just going to add those. All right, so just so you can see the formula, this piece here is LT. And then this piece up here is TS. And then the entire line segment, it starts at L and it goes up to S. So that's going to equal LS. All right, and we said LT from L to T is 380. And from T to S we said is 360. And that equals 740. So that equals LS. Okay, we can see the units are MI, that's miles. So if you want to include the units, that's 740 miles. Okay, let's try the guided practice problem number 3. It says use the segment addition postulate to find XZ. Let's take a look. So see if you can find XZ, the distance from X to Z. And also, please don't just add. Please try to write a math formula as well. Okay, so if we want to find XZ, we're going to have to add this piece, which is XY, and also this piece, which is YZ. All right, so XZ is going to equal XY, which you can see is 23. And YZ, which you can see is 50. So 23 plus 50 is just 73. All right, number 4, in the diagram WY equals 30. Can you use the segment addition postulate to find the distance between points W and Z? Let's take a look. Okay, so I labeled WY to be 30, and they want to know if you can possibly find the distance from W to Z. So think about that for a second. Okay, so is it possible to find this distance? And the answer is no. Okay, and the reason is because this point Y is not between W and Z. Okay, so Y is not between W and Z. Okay, if we had WY and YZ and Y was right here, then we can just add them. Okay, but since Y is not in between them, you can't do that. So the points are not collinear. All right, example 3, use the diagram to find GH. All right, so here's our diagram. We want to find GH right here. Now, I know some of you can do this without writing a formula, but it's really better to write the formula, and I just want to make sure you know how to do that. So if we add the two smaller pieces, okay, if we add FG and we add the other segment, this one right here, GH, so FG plus GH, and that should equal the whole thing, which is FH. Okay. Now we can see from the diagram, FG is 21. GH we don't know. And FH is from F to H. That's the whole thing, 36. Now, solving for GH, it's the same as solving for X. So we just do minus 21 on both sides. 21 minus 21 cancels. Bring down the GH. And 36 minus 21 is 15. Okay, so line segments that have the same length, those are called congruent. Okay, and the symbol for congruent is an equal sign with the squiggly line on top. So it says line segments that have the same length are called congruent segments. In the diagram below, you can say the length of AB is equal to the length of CD, or you can say AB is congruent to CD. All right, so if you look at line segment AB and line segment CD, they both have this little mark on each one, okay? So that means they are congruent, okay? That means those are the same length. Also, you can use more than one mark. You'll see in some cases that the two congruent segments, they'll have two marks like that, and that will show you or indicate which ones are congruent or the same length. In some cases, you might see it with three marks, okay? If they both have three marks, that means they're both the same length. So right here, the difference between equal and congruent, they're basically the same thing. But when there's no bar on top of the letters, you use the equal sign, okay? Because that's referring to the length. But when there is a bar on top of the two letters, you use the congruent sign. So when there's no bar on top, that refers to the length. So if, let's say AB was 5 centimeters, you can write AB with no bar on top. But technically speaking, it doesn't make sense to write AB with a bar on top and associate a number with that. So technically speaking, that is incorrect. Okay, this one is correct, but when you put the bar on top, you can't really put a length to it. So with the bar, it's congruent. With no bar, you say equals. So if you want to find the distance between 2 points, if the x or y coordinates match, there's only 2 steps. You want to ignore the x or y coordinates that match, and then subtract the other coordinates and take the absolute value. So let's take a look. All right, so let's say we have points A and B, and we want to find AB. Now you can see here the x coordinates match, -3 and -3. Let me label these. I'll call this x1, y1, and I'll call this x2, y2. All right. Now you can see the x coordinates match. They're both -3. So we can ignore the -3. And in order to find AB, we're just going to take the absolute value and we're going to subtract y1 minus y2. Or you can do it the other way around. When you subtract with absolute value, it doesn't matter. Okay, so y1, we see that's 5. And y2, we see that's 1. So 5 minus 1 is just 4. And when you take the absolute value of 4, it just stays the same. Okay, one more example. See if you can get this one real quick. Okay, we want to find CD. I'll just label this once again, x1, y1, x2, y2. Remember, the x coordinate is always the first one, and the y is the second one. So you can see the y's match, so we can ignore the negative ones. Okay, and then for CD, we're just going to subtract x1 minus x2 and take the absolute value. So x1 is negative 5. x2 is positive 2. Negative 5 minus 2 is negative 7. And when you take the absolute value, that is positive 7. Okay, whenever you measure a length, it's always going to be positive. That's why we do absolute value. Now for this method, you want to remember that both x's or both y's have to match. Okay, so if you have negative 7 comma 2 and 5 comma negative 7, this negative 7 is an x, but this negative 7 is a y. Okay, so you can't just cancel the negative 7 and then do 5 minus 2. That is not going to work. Okay, it has to be both x's or both y's that match. Okay, example 4, it says, plot J, K, L, and M in a coordinate plane, then determine whether J, K, and L, M are congruent. All right, let's not worry about the plot or graph for right now. I want you to please try to find JK, the length of JK, and the length of LM, and then tell me if they are congruent, please. All right, if you look at JK, remember the first coordinate is X and the second coordinate is Y. So you can clearly see that the Y's are both 4. So I am going to ignore the 4's. Okay, and now for the other coordinates, the X coordinates, I'm just going to subtract and take the absolute value. So I'm going to do negative 3 minus 2. And negative 3 minus 2 is negative 5. And when you take the absolute value, it's positive 5. Okay, now let's do LM. I'll do it in a different color. For L and M, again, X is first, Y is second. Okay, and we can see both X's are positive 1. So I'm going to ignore the positive 1, and I'm just going to subtract 3 minus negative 2. 3 minus negative 2. So what happens with two negatives in a row? That's a positive. 3 plus 2 is just 5. And taking the absolute value does nothing. It's still 5. So the answer is yes, JK is congruent to LM. Okay, we will worry about plotting points some other time, but this is basically what it looks like. Because the X or Y coordinates match, the line is either going to be horizontal or vertical, straight left, right, or straight up and down. This is why we can ignore the coordinates that match. You see here, these points are both at Y equals 4. So we can ignore the 4's and just count 1, 2, 3, 4, 5. Okay, and on the other line segment, same thing. They're both at X equals 1. So we can ignore the 1 and just count 1, 2, 3, 4, 5. Okay, like I said, we'll worry about plotting points some other time. All right, last one for this diagram here. I want you to please write the equation for the segment addition and find WX. Okay, I know many of you can just do it in your head or on the calculator, but also just make sure you can write the equation. Okay, so segment addition, we're going to say this piece, which is VW, and then this piece here, which is WX. I'm going to add those two. And that's going to equal the whole thing, which is VX. Okay, and now I can plug in the numbers. I can see VW is 37. WX we don't have. Okay, that's this piece right here. And the whole thing, VX, is 144. And of course, it's the same as solving for X. You just do minus 37 on both sides. Cancels here. Bring down your WX. And that equals 14 minus 7 is 7. That equals 107.